So in the previous video, we looked at try-catch blocks and how they handle thrown exceptions. Well, in this video, we're going to look at the types of exceptions that can be thrown. And there's two types, checked and unchecked. So after this video, you'll understand the difference between the two and the different things that you need to take into account when programming to handle those types of exceptions. So like I said, there's two types of exceptions, checked and unchecked. Checked exceptions are required to be checked with a try-catch mechanism. Unchecked exceptions, on the other hand, are not required to be checked with try-catch mechanisms, but you can. So how do you tell whether a particular exception is checked or unchecked? Well, you look up the associated class in the API documentation. On the class's API page, look at its class hierarchy tree. If you find that the class is derived from the runtime exception or the error exception class, then it's an unchecked exception. Otherwise, it's checked. Here's the class hierarchy for the exception class. Remember back to all the examples where we were reading different types of primitives from the console? Notice how we could still run the program even with a method that throws an exception without handling the potential errors. Well, that's because nextInt, nextDouble, etc. threw an input mismatch exception, which is derived from the runtime exception class. So let's take a look at an example of looking at the APIs. So in the scanner class, we're going to look at the nextInt method. So here you can see we're in the scanner class, and we're going to go down to the methods and look for nextInt. Right? Has nextInt. Nope. Next. There we go. So we click on that, and you can see here that it throws three different types of exceptions: an input mismatch, no such element, and a legal state exception. All right. So and you can read here why it's thrown. So if you close the scanner, which is a method that you can call, and then try to run nextInt, you're going to throw an illegal state exception. It's like, hey, if the scanner object is closed, you can't do any operations unless you open it. No such element, okay? So if there's nothing in the input buffer, and then input mismatch, if the next token does not match the integer regular expression or is out of range. So a regular expression is a tool or utility that's used to parse strings and find certain information. So it's what runs behind the next integer method to check to see if it's actually a number, right? So right here is where you can see what is thrown. If we click on the input mismatch exception, you can see that you can look that it's a part of the it extends the no such element exception, right? Which is derived from the runtime exception element, right? So if you remember, if it's thrown from a runtime exception or from an error, it is a unchecked exception. And so we can still execute it without having a try-catch block. So this is how you look at the API and you figure out, okay, is error or runtime exception in my in my class hierarchy, that's what this is right here. This is derived from this is derived from this is derived from this, so on and so forth. Okay, so that's how you can use the API to see what type of exceptions are thrown when you're using the different methods. So as you know by now, unchecked exceptions are not required to be checked with a try-catch mechanism. However, at runtime, if an unchecked exception is thrown and now not caught, then the program will crash, or as we call, terminate ungracefully. Okay, so this right here is not graceful. All right, never ever ever would you want to encounter this as a user, would you? Like all of this in here, that's just ugly. You don't want to see that. And then what about the state of the program that you were in when you were running it? So we want to make sure that we don't get into these positions. So how do we handle an unchecked exception then? Well, we have two choices. We can either A, use try-catch blocks just like a checked exception, or we can write better code that avoids the exception altogether, right? So we do some input validation to make sure that our inputs are good before we try the risky method or the dangerous method. Okay, so let's look at another example of using the try-catch blocks to handle an error. So this is a simple class called getInFromUser, and all it's going to do is get an integer from a user, right? Complicated. So here we have a scanner object. We have our temporary string variable to hold our string. Then we have this Boolean valid to see it's a input validation check to see if our entry is valid. And then we have a temporary storage for our integer that gets converted, right? So our program is going to prompt for an integer, and then it's going to store that string in the X string value. And then it's going to do this loop right here, and then it's going to try to convert the string into an integer, right? And so it automatically sets valid to false because it's like, hey, I want to check it. I don't want to set valid to true until I know for a fact that it is in fact an actual integer, right? So, and then if it is, it's going to set it to true. If it's not, it's going to jump down to this catch block, catch the number format exception, print out a message to the user, and then it's going to try to read it again, right? And it's going to do all of that while valid is not true, so while it's not valid. So let's go ahead and run it. We're going to compile. Oh, look at that. We got an error. Why? It says variable might not have been initialized. Right there, valid. And X might not be initialized. So what this is highlighting is the fact that the compiler is pessimistic. So when it's compiling the code and it gets to this try section right here, it's going to assume the worst. It's going to assume that this is going to fail, and it's going to throw a number format exception. So anything that's inside of the try that gets initialized, if it's not initialized outside of the try block, guess what? You're going to get that might not have been initialized error. Okay? So the question is how do we fix it? Well, very easily. All we do is we initialize the variables up here, so that way they actually have a value. They've been assigned a value. So now if we run this, you can see, hold on, I gotta compile this one first. All right, look at that, it actually compiles, and now we can test for an integer. Hey, great, 5 works, right, as expected. All right, let's try X. What happens? Oh, invalid entry, enter an integer. 3.2, invalid entry, enter an integer. Negative some really large number, right? Invalid entry, enter an integer. Why did this fail? Well, because it was too big to be stored in an integer value, right? So we can hold up to what, 4 billion and something? So if I do 3,000,000,000,000, that doesn't work either. It's too big, right? 3,000,000,000. There we go. So see, there you have it. So that is using the try-catch method of handling an unchecked exception. So let's take a look at another example to show you the other way of doing it, which is with handling it with better code, right? So here we have two classes called student list and student list driver. And student list is a class that just simply holds a list of names. So you can see here we're using an array list of type string to store our students, and we have our constructor here where we pass in an array of names and we add those names to the list, right? And then we have a display method which sits there and iterates through the students and prints them out, right? And then here we have a method called remove student at index whatever's passed in, and it removes the student. And here we have our driver where we enter 4 students and we try to remove them, right? So what do you think is going to happen? Let's compile this. Compiles fine. If we run it, look what happens. Index out of bound exception, right? Index 6. Well, that's because there's only 4 kids or 4 students in our student list. So how can we go about making this more robust, right? That is the question. Well, based on our previous methodology, we would have done something like this, right? Well, here, let me actually just comment this one out. There we go. So we would have done something like this, where we try to remove the student and we would catch the exception and say, hey, we can't remove that student because the index is not valid. So if we save this and compile it and rerun student, guess what? Look at that. It didn't crash on us. It just gave us an error message that said you couldn't remove student 6 because it's invalid position. All right. Okay. Well, that's good. But we said we wanted to look at a different way of doing it. We wanted to do it with more careful coding. So how could we go about doing that? All right. Well, let's comment this out and show you another way of doing it. So here you can see we have the same method, remove students, and this is using if else to handle it. It says if index is greater than or equal to 0 and index is less than student size, then we will remove the index. Otherwise, print the error message, right? So if we go ahead and compile this, and now we run this, look at that, same result. So what's the difference between the two? Well, as the book will tell you, if you can, this is actually the preferred way to handle the exception because it is more performant, meaning it has better performance. It will, if you run the try catch, it's going to involve the compiler creating a catch object and all the associated operations that's part of that operation of creating the object. So this is more streamlined, and so it's going to be more efficient. Does it really matter on a trivial program like this? No, absolutely not. Does it matter if you're doing something that's checking things 1,000,000 times a second? Yes, it does. So if you're not to that scale, don't worry about it. I'm not going to, if you know, on a homework, I would prefer you actually do the try catch just so you get more practice with it, because you should be able to figure this out. This is kind of new and this is a little bit different for you. So, but either way, you can do either method for catching exceptions that are unchecked. If a code fragment has the potential of throwing a checked exception, then the compiler requires that the code fragment have an associated try-catch mechanism. So this is different from our unchecked exceptions where we could do either or. We could do the try-catch or we could do careful coding, right? But with checked exceptions, you must have a try-catch block to make the compiler happy, right? So if there's no associated try-catch mechanism with that part of the code, then the compiler will generate an error. So we're going to take a look at that. So here we have a class called create timestamp file, right? And we're using the file package and the date. So relatively new. We haven't seen these yet. Here's the path object that's going to store the file location. We got a file name string and we got a timestamp string. So our timestamp is equal to a new date object to string. And so whenever you generate a new date object with the default constructor, it's going to default to the current date and time, right? Now our file name is going to be equal to the timestamp, but we're going to replace all of this blank spaces with underscores, right? And we're also going to replace all colons with underscores. And then we're going to add .txt to the end of it, right? And then we're going to set our path equal to get the file name, the path for the file name, right? So let's go ahead and run this, see what happens. Hey, look at that. What do you know? An error. Error, unreported exception, IO exception, must be caught or declared to be thrown, right? So that's telling us that, hey, this is a checked exception. We have to catch it, all right? So let's take a look at that. Let's open up the other version of the file. Right here you can see the same thing, but we have a try block for the two checked exceptions, the IO exception and a file already exists exception. And how would we know that? We would look at the API documentation, right? And we're going to catch these. And it says, since IO exception is a superclass of file already exists exception, we can just use this single IO exception instead of having both file already exists exception and the IO exception, right? So if we try running this, here you can see that it created a file called Saturday, March 17th at 11:46 and 21 seconds Eastern Daylight Time, right? 2018.txt. Right, so if I pull up my my browser, look at the code section, right? What did it say the file was created as? Saturday, March 7th. So if I scroll down here, hold on, let me fit it into the window. You can see right there, it created a file. Now that's all it did. It created a file. It didn't actually put anything in the file, but you can see that it did what it said it was going to do. It created the file. And it had to have this try-catch mechanism surrounding these two blocks because they throw an IO exception and a, well, not the system.out, but the file's create file, right? So there you have it. That is how you can, you have to use a try-catch for a checked exception. So whenever you want to use a method or constructor from one of the API classes and you're not sure about it, you should look it up in the API documentation so you know whether to add exception handling code to it, right? I foot stomped this tons. You know, you got to get comfortable with looking at the API documentation. So first, check to see if the method constructor call possibly throws an exception, right? On the API documentation page for the method or constructor, look for a throws section. If there's a throws section, that means that the method or constructor can possibly throw an exception. If the method or constructor call throws an exception, is it checked or unchecked, right? And how do we know? Well, on the API documentation page for the method or constructor, drill down on the exception class's name. And then on the documentation page for the exception class, look at the exception class's hierarchy. If you find runtime exception is an ancestor, then the exception is an unchecked exception, right? Otherwise, it's a checked exception. So let's run through this process with an example. Let's use the create file method in the file class. First, we pull up the java.io package and click on the file class. Once there, we navigate down to the create new file method and click on it. And from here, we can see that the create new file method throws an IO exception right here. We can see here that it throws an IO exception, so now we just need to figure out if IO exception is a descendant of runtime exception. So let's click on IO exception and have a look. So we clicked on IO exception and we can see that IO exception is not a descendant of runtime exception. Right? We check right here and we do not see runtime exception anywhere. So we know that this method is a checked exception, and now we must include it in a try-catch block. All right. If the method or constructor call can possibly throw a checked exception, again, you have to use try catch. If the method or constructor call can possibly throw an unchecked exception, you should read the documentation to figure out the nature of the exception, and then depending on the situation, you can either use a try catch or just use careful coding to make sure that you're handling it.